Engineers Career Group online GATE crash course. Today's topic is transient analysis. We will be studying transient analysis for DC and AC circuits. For DC and AC transient circuits. DC transients are divided into three major categories. First is source free RLRC circuits, then with source circuits, and last is your transients with condition, like for t is equal to some value, t is equal to t dash, initial and final condition. Let us first discuss basic concepts of transients. Supposedly, I assume that we have this circuit in which we have first of all a switch which is connected to point A before time t is equal to 0, and at time t is equal to 0 this switch is shifted to the other side. This circuit at t is equal to A and at t is equal to B. At t is equal to A, this circuit is with source circuit. In this circuit it will be charging, and when this switch is shifted to point B, this circuit becomes source free circuit. In this portion it will be discharging. Now we will write charging equation for my RL circuit. Let us assume at time t is equal to 0, or say before switch was closed, the initial current in my inductor was 0, and current in inductor rises exponentially according to the equation I naught 1 minus e raised to power minus t by tau, where tau is your time constant is equal to L by R. Now this is my charging equation for inductor. Initially at t is equal to 0, the current in inductor was 0 and it rose accordingly to the value I is equal to I naught, which is the maximum value current will acquire in this circuit. Now this is again my charging part. We assume that after 5 tau, this will become a constant value I is equal to I naught. The period in between 0 to 5 tau is known as transient state, and after 5 tau it is known as steady state. Now you can see, we all know that we have discussed in our previous lectures that V is equal to L di by dt for inductor. Now in this portion from 0 to 5 tau, IL is variable. Therefore, VL will be equal to non-zero. Why? Because V is equal to L di by dt. If IL is variable, then VL will be equal to non-zero. At this point, IL is equal to constant. If IL becomes constant, then differentiation of constant becomes 0, and therefore VL is equal to 0. Now you can see that initially my value of current IL was 0. We all know if current is 0, initially the inductor will act as open circuit. Now in steady state my VL is equal to 0, and we all know when VL is equal to 0, wire acts as short circuit. Therefore inductor initially acts as open circuit and finally it will act as short circuit. At this point inductor will have maximum energy of half Li square, and at t is equal to tau, inductor will achieve its value 0.638 of I naught, that is maximum value. This t is equal to tau is my t is equal to time constant, and here L by R means that poles of this circuit are lying on t is equal to L by R. Now we talk about discharging, that is this was when the switch was in position A. After it has achieved its steady state, the switch is shifted to position B. This is circuit for position B. This circuit is basically source free RL circuit. Now we We all know that inductor was fully charged. A fully charged inductor will act as a current source for the circuit. And the value of current source I is equal to I naught, which was the maximum value it was charged to. Therefore, when the switch is shifted to position B, firstly, it has a maximum value of I naught. There is no energy element. So the whole energy is dissipated across the resistance and this inductor will discharge to the value 0. Now, we can see that it started from I is equal to I naught. The discharging equation is equal to I naught e raised to power minus t by tau. This is discharging equation for the inductor circuit. The value here is I is equal to I naught and here value is I is equal to 0. Why? Because the whole energy is dissipated in the circuit and the current in inductor becomes 0. At this point I is equal to 0, V is equal to 0 and E is equal to 0. That is, there will be no voltage in the circuit, no current in the circuit and no energy in the circuit. Now I is equal to I naught e raised to power minus t by tau is discharging equation for inductor circuit. Let us assume this again we are switching the position, so we have made it from 0 to 5 tau. Now we have again switched the position, we are making it for 0 to tau. At 0 to tau in discharging equation, the value of the circuit becomes 0.362 of I naught. And this is again 5 tau. Here you can see that I is variable, therefore VL is equal to non-zero. Here IL is equal to 0. We all know VL will also become 0. So this is basically charging equation for my inductor. This is basically discharging equation for my inductor. What are the important points that we have to take from here? The important points are inductor current, that is IL is equal to 0 initially. It charges up to the value I naught. Initially the inductor will act as open circuit and after charging it will act as short circuit. Whenever the inductor is shifted to a source free circuit, here the inductor will act as current source and it will dissipate its energy across resistance and become eventually 0. Now the voltage is variable when the inductor is in transient state and it becomes 0 when it is in steady state. Maximum energy that inductor will acquire is half Li square when I is equal to I naught, that is half Li naught whole square, where I naught is the maximum value of the current that will flow in the circuit. So this is all about charging and discharging of inductor circuit. Now we will study basic concept of charging and discharging for capacitor circuit, because transients are only observed in networks which contains passive elements, that is inductor and capacitor. Now supposingly we have a network which again contains a capacitor. There are two switch positions A and B. Position A is when capacitor is charging with the voltage V, and it is shifted to position B when capacitor is in source free circuit to position B. Again we have to make graph for charging and discharging of capacitor. Initially voltage in capacitor is equal to 0. At value tau it is similar to charging and discharging in inductor. At value 5 tau, this value will reach its steady state value, V is equal to V naught. This is again the highest point of energy. This state is called steady state and this state is called transient state. Now we all know C is equal to dV by dt. Sorry, I is equal to C dV by dt. Therefore, if voltage is variable in this state, the current here is constant or changing value. There will be a current which is not equal to 0. Here VL is equal to constant. Therefore, current will become 0. Now initially if voltage is 0 for any device, it will act as short circuit, and if current is 0 in any device, it will act as open circuit. Therefore capacitor will initially act as short circuit wire and after complete charging it will act as an open circuit. Now energy of capacitor is half CV square, which is the maximum energy it can acquire. It is, you can write the half CV naught square if you are writing V naught as the maximum energy. Again it will discharge. The capacitor charging equation is equal to V naught, V of t is equal to V naught 1 minus e raised to power minus t by tau, where tau is equal to 1 by RC for my capacitor circuit. Now again this point has come, 5 tau. At 5 tau the whole voltage in this circuit is 0, current in this circuit is 0, and therefore energy in this circuit is 0. Discharging equation is equal to V naught e raised to power minus t by tau for this circuit. Now capacitor after complete charging, when this is my switch position A similar to induction, and this is my switch position B. Now this circuit becomes a source free RC circuit. Whole energy is dissipated across the resistance. I have already discussed that initially inductor will act as a current source. Now we can see that capacitor will act as a voltage source. Now let us take the important points that we have to take. First, initially voltage in capacitor is 0, therefore it will act as a short circuit, right? After charging, the voltage in capacitor changes to V naught. Therefore, after complete charging, it will have 0 current, therefore it will act as open circuit device. When this capacitor is shifted to a source free circuit, it will act as a voltage source of value V naught. Again in this region, VL is variable, therefore IL is equal to non-zero quantity. And after this, when VL becomes 0, IL becomes 0, and energy in the capacitor is dissipated across the resistance. This is my discharging, this is my charging. The value of tau is again 0.362 V naught. This is my value of tau for charging, value of tau for discharging. This is complete basics for capacitor and inductor. Now again what we have to take from this, that inductor initially act as open circuit, finally short circuit at steady state. Capacitor will initially act as short circuit and finally it will act as open circuit. If you are clear with these concepts, now we will discuss about transients, and we will discuss DC transients in detail.
We have already discussed about basics of how charging and discharging takes place in inductor and capacitor. Now we will discuss some important points regarding inductor and capacitor. We have already discussed that inductor initially act as open circuit. Why? Because current in inductor is equal to 0. That is IL0 is equal to 0. Now inductor has a property that current in inductor does not change instantaneously. And how? Let us discuss that. We know that current in inductor is equal to if I have to calculate current for IL0 positive, how will I write it? This quantity can be written as I0 negative. Why? Because we were writing for 0 positive, we have substituted T with 0 positive. Now for 0 negative, we can write it as 0 negative. And this quantity is 0 for all practical application of circuits. Like for any practical DC source, this quantity will be equal to 0. Therefore, we can see that I of 0 positive is equal to I of 0 negative in case of inductor. Therefore, we can say that current in inductor do not change instantaneously. That is, whatever the current will be at 0 negative, same value will be retained at 0 positive. Initially, if we are talking about discharge inductor, IL0 negative will be equal to 0. Therefore, IL0 positive will be equal to 0. Always remember that current in inductor do not change instantaneously. We can do the same for capacitor as well. Capacitor initially acts as short circuit, that is Vc of 0 is equal to 0. That is, initially it will act as short circuit. Similarly, we can write equation for capacitor as VCT is equal to, you can write it as Vc of 0 positive will be equal to 1 by C minus infinity to 0 positive. Again, this quantity is 0 for all practical applications, and this will be written as Vc0 negative, and we can see Vc0 positive is equal to Vc0 negative. Therefore, voltage in capacitor do not change instantaneously. Now this is about practical sources. In case we give a DC excitation, that is, I am talking about delta source, like if I gave input as delta T, my V of T is equal to delta T in case of inductor, then what will we write? Again we can write I of T is equal to minus infinity to T 1 by L V dt. You can write 1 by L is equal to minus infinity to 0 negative plus V dt plus 0 negative to 0 positive V dt plus 0 positive to whatever the value it is V dt. Again 1 by L, 1 by L. This is 0 because we know delta is 0 for the whole left domain. This is also 0 because we know delta is 0 for whole right domain. Therefore, I of T will be equal to 1 by L into 0 negative to 0 positive of V dt. This will be equal to 1 by L. You can see that if we give an impractical source, that is delta T, the current in this circuit will be equal to 1 by L. Energy will be similarly equal to 1 by 2L, and you can derive the same expression for capacitor as well. Voltage in capacitor for DC excitation is equal to 1 by C, and energy will be equal to 1 upon 2C. These are some important points, that inductor do not respond to instantaneous change in current, capacitor do not respond to instantaneous change in voltage. Now we will discuss equivalent circuits of capacitor and inductor. We have already discussed that if we are talking about RL circuit and R is my resistance, L is my inductor, then equivalent circuit for this inductor will be a current source in parallel to my inductor circuit. And for my capacitor, the equivalent circuit is a capacitor in parallel to a voltage source of amount V. This is my IL, this is my VC. Initially, inductor has to be charged with the quantity IL, and initially my capacitor has to be charged with the quantity VC. These are my equivalent circuit for my capacitor and inductor. Now let us come to DC transients, how to calculate them. First of all, let us discuss DC transients source free. We have already discussed that tau for inductor is L by R and tau for capacitor is equal to 1 upon RC. Let us first discuss how to do DC transients in source free circuit. Suppose this is the circuit. Before t is equal to 0, the switch was at position A. Now after t is equal to 0, the switch will move to the position B. In this circuit, we assume that this circuit was in steady state. Now we have to do, in order to solve any DC circuit, we have to make three major circuits. Circuit for at t is equal to 0 minus, then circuit for at t is equal to 0 plus, and then last at circuit for t is equal to infinity. And we have to remember that IL0 negative is equal to IL0 positive because current and inductor do not change instantaneously. Now for at t is equal to 0 negative, the current circuit will be, because this is Short circuit, we have already discussed that inductor will act as short circuit. Current in this circuit will flow as 3 ampere at 0 negative. For 0 positive circuit, this is the source of 3 ampere and this is my resistance R. Now we can calculate anything that is required, like voltage across this or any other thing that is asked in question. Last is at t is equal to infinity, this will be 0, therefore the circuit will be this for t is equal to infinity. Now according to question, they ask you different type of things, like they ask you IL0 minus IL0 plus, VC0 minus VC0 plus and so on, and you have to answer accordingly. Now there are important points that you should know about DC transients. First of all, inductor initially acts as open circuit, at steady state it acts as short circuit. Capacitor initially acts as short circuit, at steady state it acts as open circuit. Current in inductor do not change instantaneously and current in capacitor do not change instantaneously.
Subscribe to us now.